Hi guys, today's video is going to be about absolute value inequalities. So the first thing that we need to look at is that there are two types of absolute value inequalities. There are greater than and greater than or equal to, and there's less than or equal to. So we are just going to take an example of each one. So if we know that the absolute value of x has to be greater than or equal to 7. This value of x, so if this were equal, we would say that x could be -7 or +7, correct? So let's just go ahead, this says it's equal to, let's just go ahead and mark those on our number line. Now, if we are looking at our number line and we know that the absolute value means the distance from 0, and we know that that has to be bigger than 7, then anything between these two is going to be smaller than 7 and is not going to work for our function. So we know that only the numbers that are more negative than -7 and more positive than +7 are going to satisfy this inequality. So in interval notation, this is -infinity to -7 with a bracket in union with +7 to +infinity. Okay, and if you remember from our last videos, this is an OR inequality. X is less than -7 or greater than +7. So let's look at the less than or less than or equal to. So we know that the absolute value of x has to be less than or equal to 4. So if it were equal to 4, our options would be -4 or +4. And we want the value to be less than that. So that's going to be all of these in between +4 and -4. And in interval notation, that looks like -4, 4 with brackets because the 4s are included. And this is an and inequality, if you remember from our last video on compound inequalities. Because x is greater than -4 and less than +4. All right. So what does this tell us about absolute value inequalities? This tells us that all absolute value inequalities are compound inequalities, which we have already learned about. And we saw that if we have absolute value of x is greater than or equal to some number a, then that is going to give us an OR inequality. Those are the ones that we have to use a union symbol for, and they look like two separate things on our number line, okay? So these are all characteristics of an OR inequality. We know that if absolute value of x is less than or equal to some number a, that is an AND inequality. And AND inequalities are just one, they're bracket to bracket or parenthesis to parenthesis, or it could be brackets and parentheses. So we don't use the union symbol, and it looks like between 2 points. Okay, so let's look at some examples. You can pause the video and write down these steps, but I'm not going to read them to you because they're not going to make a lot of sense until we actually apply them. So let's look at the first practice problem. Our instructions tell us to isolate the absolute value expression. So that is the stuff that is between the absolute value bars, and that just means that we want it alone on one side of the inequality, and that is already taken care of. So we have done number 1. Then it tells us to create 2 cases, and it says to use the KISS method to set up the 2 cases. So I'm going to show you what that means. So for the first case, everything stays exactly as is, but with no absolute value bars. So we have x plus 6 is greater than 7. Then it says to keep it, switch, switch. That is our KISS method. So you keep the absolute value part, you switch the sign, and you switch the inequality symbol, and you switch the sign of the other side of the inequality. So we keep this, and then we switch, keep it, switch, switch. Then we're going to solve both inequalities. So we're going to subtract 6 from both sides, and we get x is greater than 1. And then on the other case, we're going to subtract 6 from both sides, and we get x is less than negative 13. And remember that when we have a greater than inequality, that is an or inequality, so our graph should look something like this. That's not exactly what it'll be, but it should look like that. So let's go ahead and graph this. X has to be greater than 1, not equal to though. So here's 1, and we want it greater than. It's an open circle because it cannot equal 1. And then x is less than negative 13. So here's negative 13. It is not included. And our interval notation is negative infinity to negative 13 with a parenthesis in union with positive 1 to positive infinity. Okay, let's try number 3. Again, number 3 has already isolated the absolute value expression for us, but now we'll create 2 cases. So the first one stays exactly the same, but without the absolute value bars. And the second one, we keep it, switch, switch. So we're going to keep negative 5 plus k over 3. We're going to switch the inequality and switch the sign of the right side. All right, so let's solve the first one. Add 5 to both sides. And we get k over 3 is greater than or equal to 6. Multiply both sides by 3. And we get k is greater than or equal to 18. We'll solve the other one. Add 5 to both sides. K over 3 is less than or equal to 4. Multiply both sides by 3. And we get k is less than or equal to 12. And remember that a greater than or equal to inequality will become I lost my train of thought, an or inequality. So k is greater than or equal to 18. And k is less than or equal to 12. So our interval notation is negative infinity to positive 12 with a bracket this time, and then 18 to positive infinity. Okay, so for number 5, we actually do have to complete step 1, which is isolate the absolute value expression. So we need to get this part of the equation by itself. So that is being divided by 4. The opposite of dividing by 4 is to multiply by 4. So we're going to multiply both sides by 4, and we'll get the absolute value of q minus 1 is greater than or equal to 8. So now we create our 2 cases. So we have q minus 1 is greater than or equal to 8, and then we keep it, switch, switch. And then we solve. So we have q is greater than or equal to 9. We're going to add 1 to both sides here as well. and we get q is less than or equal to negative 7. Okay, so we created two cases. We solved both. Now we're just going to graph. So q is greater than or equal to 9. So since it can be equal to, we fill the circle in. And then it's less than or equal to negative 7. So negative 7 and to the left. And then again, our interval notation is negative infinity to negative 7 with a bracket in union with bracket 9 positive infinity. Whoa, that's sloppy. Let's try that again. There you go. All right, so let's try number 7. First, we need to isolate the absolute value expression. We're going to do that by dividing both sides by negative 10, because the opposite of multiplying by negative 10 here is to divide. Those will cancel. We get the absolute value of 2r minus 1 is greater than or equal to positive 6. Remember, with inequalities, whenever you divide or multiply by a negative, you have to flip the sign. So this changes to a greater than or equal to inequality. All right, so now we create our two cases. We have 2r minus 1 is greater than or equal to 6, and 2r minus 1 is less than or equal to negative 6. And then solve both. 2r is greater than or equal to 7. Divide both sides by 2, and we get r is greater than or equal to 7/2. And if you can write these as a decimal, that's usually easier to graph. So we're going to call this r is greater than or equal to 3.5. All right, then we're going to solve the other one. Add 1 to both sides. 2r is less than or equal to negative 5. Divide both sides by 2, and we get r is less than or equal to negative 5/2. Once again, when we can write it as a decimal, it is easier to graph that way, usually, for most people. So we've created both cases, and we've solved both of them. Now we're going to graph. R is greater than or equal to 3.5. So 3.5 is right here, and it's greater than or equal to that. So we filled in the circle. And then r is less than or equal to negative 2.5. So here would be negative 2.5, and it's less than or equal to. So interval notation is negative infinity to negative 2.5 with a bracket in union with 3.5 to positive infinity. Let's look at this again. Isolate the absolute value expression. So we need to, not add. The opposite of addition is subtraction. So we'll subtract 7 from both sides. We get 6 times the absolute value of negative 5n is greater than 30. Divide both sides by 6. And we're going to get negative 5n, absolute value of negative 5n is greater than 5. And then we're going to create two cases. Negative 5n is greater than 5, and negative 5n is less than negative 5. Now let's solve these. We're going to divide both sides by negative 5. And remember, when you divide or multiply by a negative, you have to flip the sign. So this one turns into n is less than negative 1. Divide both sides by negative 5 again. These cancel, and we get n is greater than positive 1. We had to switch our signs on these. So n is less than negative 1. We graph that like this. N is greater than positive 1 is graphed like this. Let's make that a little better. There we go. And then interval notation will be negative infinity to negative 1 with a parenthesis this time because it cannot equal negative 1 in union with positive 1 to positive infinity. And here's our last example before I let you practice on your own. Okay, add 9 to both sides. And we're left with 3 absolute value of 8x plus 5 is greater than or equal to 33. Then we're going to divide both sides by positive 3. We get absolute value of 8x plus 5 is greater than or equal to 11. Then we're going to create two cases. 8x plus 5 is greater than or equal to 11. 8x plus 5 is less than or equal to negative 11. All right, then subtract 5 from both sides. 8x is greater than or equal to 6. Divide both sides by 8, and we get x is greater than or equal to 3/4. And this number is also known as 0.75. Okay, over here we're going to do the same thing. 8x is less than or equal to negative 16. Divide both sides by 8, and we get x is less than or equal to negative 2. So let's graph it. I also just realized that I didn't show you any problems where, not a single one of the odd problems was the type where you color in between. So make sure you watch out for those on the even numbers. There will be some where it's in between the two and not, where it's and instead of or. Sorry. All right, x is greater than or equal to 0.75. So 0.75 is about right here. It doesn't have to be perfect. And it's greater than or equal to that. And then x is less than or equal to negative 2. So this is going to be negative infinity to negative 2 in union with positive 1 to positive infinity. All right, so remember they can be and type. We just didn't have any examples in the odds like that. Thanks for listening.